Hello, everybody, and welcome to Algorithms and AI, Artificial Intelligence, the Future of Communication. I'm Dr. Jessica Eise, and this lecture is part of a short course that is an introduction to the basics of an algorithm and artificial intelligence in a communication context. As always, let's just quickly recap the goals of this course before we jump into the meat of the lecture. So the goal is to help you work intelligently in a digital environment and to stay on the vanguard of communication innovation, as well as to confidently approach complex digital topics with a base of knowledge. So we're going to move into the second lecture of this short course, which is what is artificial intelligence? All right. So what is artificial intelligence? Great question. In our last lecture, we reviewed what algorithms are. So we're laying the foundation for us to understand the basics of artificial intelligence. In general, artificial intelligence is not well understood in society. And we can probably blame that on a lot of things. For instance, media and pop culture regularly portray AI to be something that it really isn't. So think portrayals of like highly sophisticated robots that are capable of incredibly complex action and that sound and look like human beings and kind of seems like they're acting on a set of principles, for instance. Another reason why we might not have a very good understanding of artificial intelligence in society is we just don't have proper education around it, which is not unusual when there's something so new and innovative. Sometimes our like broad education efforts can kind of lag behind a little bit. But another reason is that the name itself can be a little bit misleading. So let's talk about that for a minute. Okay, we'll jump back here. The term artificial intelligence is something that often conveys like a human intelligence. And in my last lecture, I discussed anthropomorphizing language, or language that attributes human qualities to an object, and how I sometimes find that to be a little bit troubling when we're talking about machines, right? Because as a communication expert, I often focus on language and how we use language to describe things. And it can be very powerful and evocative to attribute human qualities to an inanimate object. It can also be very misleading because the way the human brain works and human intentions and human thought processes are not always very comparable to that of a logic-driven machine. So let's break down the word intelligence and see how it does and does not apply well to the context of artificial intelligence. Keeping in mind the whole time that, as we know from our last lecture, computers operate based on algorithms written into programs, so software. And we also learned that algorithms are based on logic. All right, let's jump back to our PowerPoint. So, what is intelligence? There is no agreed definition or one single model of intelligence, but by the Collins English Dictionary, intelligence is the ability to think, reason, and understand instead of doing things automatically or by instinct. So in this definition, the concepts of thinking, reasoning, and understanding are all emphasized. These are things that an algorithm-driven computer action is not exactly capable of doing. So it executes functions per its lines of code. And this definition also emphasizes not doing this automatically, but by the very essence of compiling lines of code, the machine is in some way doing things automatically. Let's look at another definition here. This is the Macmillan Dictionary definition, which defines intelligence as the ability to understand and think about things and to gain and use knowledge. So we keep coming back to this word thinking, right? So what is thinking and how is thinking associated with intelligence? So according to the Merriam-Webster Dictionary, thinking is to form or have in the mind. It's to have as an intention, to have as an opinion, to reflect upon, to determine by reflecting, to form a mental picture of, to devise up. So as we can see, thinking maybe in some ways is an extremely complex concept that maybe we don't have a totally clear definition of, but it seems very particular to the human mind. When I look at this list, things such as intentions, opinions, reflection, these all seem like things that a machine whose functions are defined by logic-driven algorithms may not possess or may not be capable of. Therefore, in the sense of intelligence as we think of it, which is a human concept involving a human brain, a computer may not be able to exhibit that type of intelligence. For instance, it can only self-originate if it is programmed to self-originate, which means, is that self-origination at all? Maybe not. Maybe it's a command that's just simply being followed to test a variety of alternatives. So let's talk about that a little bit more. I think the reason why we use anthropomorphizing language, as I mentioned earlier, is because it's evocative and it's catchy. And as new technology emerges, we often want to make it evocative and catchy. So we want to help people understand what it is, that it's different and it's exciting and it's revolutionary. And I think it's only natural that early pioneers in the field adopted words like thinking and intelligence to apply to computers, because not just because it's catchy and not just because it's alluring to the public, but also because computers are doing things that people had never dreamed possible. And to many, this did appear as though they were truly intelligent. But I think an important thing to focus on is the word artificial that's pegged on in front. If we put our emphasis on artificial, we pay attention to that adjective, things make more sense. Because artificial means fake or humanly contrived. And computer intelligence is fake. Computer intelligence in the sense that computer intelligence is humanly contrived. So when people talk about AI, artificial intelligence, computers don't think and aren't intelligent in the way people are. It is a fake or artificial intelligence driven by algorithms that are written by human beings. Another way to think about it, as one of my colleagues mentioned, Dr. Lambert, recently, is that these computer programs are able to do things that the human brain is not capable of. For instance, we cannot, inside our heads, conduct advanced mathematical functions instantaneously. We cannot manage enormous data sets and run through them without any errors in a split second. So computers are offering artificial intelligence that we are not capable of performing. So in some way, it's an artificial intelligence that we've kind of created, right? We can envision how to do it. So we can train a machine how to do it, but we can't do those types of calculations in our own head. So in that way, we might think of it too as artificial. So what is artificial intelligence then? What is it? We'll move away from breaking down the words here. What's the difference between artificial intelligence and any other program? So there are many definitions of artificial intelligence, which is in some ways part of the problem. But this is really common with complex topics that are emerging that we're slowly growing to understand. It's natural that there are many different definitions because we're still in many ways trying to figure out what it is. This is the same even with communication, which is my field. There are hundreds of different ways of defining communication still, because we're still in many ways figuring out what it means. It's a new field. I'm going to avoid, as we talk about artificial intelligence, I'm going to avoid using anthropomorphizing language as much as I can. So we'll see if I'm able to do that. But basically, a machine can only do what its algorithm commands it to do. And the algorithms are designed and written by human beings. So a human being can write or command that, create and build into this algorithm the ability to self-modify based on certain data inputs. But it will only self-modify as it has been commanded to self-modify through the instructions in its algorithm, which, as we recall, are based on strict logic. In other words, a computer can't think outside the box unless it has been commanded to think outside the box by its programmer, which in a sense, does that mean it's actually thinking outside the box? I keep coming back to these questions, but I think they're really important for us as we try to understand, really understand what artificial intelligence is. So artificial intelligence, as we kind of approach it today, we sort of see it to be designed with a clear problem-solving purpose that can solve a complex problem. So in this way, we might be trying to differentiate it from other more basic computer programs. Let's look at that. What does that mean? So an artificial intelligence algorithms can be designed to take data and produce a decision from it based on an instant analysis. So an artificial intelligence algorithm combines information from a variety of different sources, analyzes that material instantly, and then acts on the conclusions it has derived. So we can look at, for instance, self-driving cars or cars that are getting close to being self-driving. They have different remote sensors on the vehicle, such as light detection and a radar to observe, people or buildings around the car. Then it combines all this information and processes it instantly. And then it makes a very quick decision about how to navigate the car. So there's a lot of data and input, and this is received, run through the complex algorithm that then emits an output, which is the decision of how to operate and move the car. We're able to do this because we have advanced so much in our storage systems and processing speeds and analytic techniques. Basically, we've refined and advanced the foundational principles of programming. We've gotten much, much better at it than we were before. Another way we can look at artificial intelligence is as the ability to analyze complex data. So we live in worlds today where we are basically just drowning in data. There's so much data. And artificial intelligence algorithms can take enormous bodies of complex data and look for underlying trends. Based on its programming, it can look for particular data points to spot, and it can then analyze these based on other particular considerations that the programmers have indicated it to use. So whatever the program prioritizes in its considerations has been designed into it by a human being, the programmer, who is writing the code. The machine itself does not have an internal sense of ethics that guides its decisions. These are all externally imposed by the programmers. So you may have heard about algorithms that have biases in them when they're analyzing data sets. For instance, if it's analyzing human profiles, that maybe there's like a bias in the way it analyzes human profiles. The bias does not come from the machine. The bias will come from a programmer or who is writing the algorithms. And often biases are written in or could be created without people even knowing it, because many biases are invisible to us. So this could lead to a program ultimately discriminating against a group of people because a bias maybe unknowingly has been written into the algorithm itself. This is why it's important to think about values and fairness when writing programs, because values and fairness are instilled in these machines by us as humans, because machines do not have a sense of value or fairness. They follow logic commands. So what are some examples of artificial intelligence? One that I'm sure you've heard of is machine learning. So more anthropomorphizing language learning. Machine learning is considered to be responsible for the majority of artificial intelligence advancements. So what does machine learning do? There are massive amounts of data, which we discussed earlier. And data can mean numbers, words, images, clicks, whatever. The data is fed into a machine learning algorithm. The code, the algorithm, is written to try and observe patterns within this data. Based on this pattern, it can try to make predictions. As more data is input into the machine learning algorithm, it refines its ability to make predictions with the goal of getting better at it. In this sense, the more data it receives, the more it attempts to refine its analytical process to be more accurate. How does this work? Okay, remember, it's all based on logic functions. All the things we discussed about algorithms in our first lecture are still at play. There is no internal mind that is making these deductions. It's still based on the tiny building blocks of if A, then B, right? These simple logic functions. This can bring us to the concept of neural networks. And I know, more anthropomorphizing language, right? So neural means relating to a nerve or the nervous system, right? So living beings have nervous systems. And we know that machines are not living beings. So the word neural evokes thoughts of a human mind. But it is called a neural network because it was inspired by the human mind, right? So neurons are brain cells. It's an attempt to use math and computer science principles to mimic densely interconnected brain cells. This does not mean that they are brain cells. They are not brain cells. So what are neural networks? Okay. Okay, when a computer self-modifies its own program or code to perform a task by analyzing training examples. Okay, so let's look at an example. A programmer might hand label a number of examples in advance, right? So a programmer might label some examples and then feed these into the system, and then the algorithm is trained to identify patterns. So if a programmer feeds like this program, the system, 1,000 images of a cat, the program observes patterns in the images in order to be able to identify in other images what is a cat. Okay. So if the programmer has a sense of humor and labels those cat images as dog images, the program will never know the difference. A program can't know anything. It simply receives input and creates output. So if it receives 1,000 images of a cat that its programmer told it was a dog, it will label dogs as cats because it developed pattern recognition of a dog based on 1,000 pictures of a cat. All right, so let's get a little bit technical. So a neural network consists of thousands or millions of simple lines of code that are interconnected. And these are called processing nodes. Data moves through them in one direction, okay? And it moves through one node that may be connected to several other nodes in the layer beneath it. Each node is assigned a weight. To each of its incoming connections, a node will assign a number known as weight. If that number is below a certain threshold, the node does not pass any data on, so it stops. If the number exceeds the threshold value, the node fires, right? So it sends the number to all its outgoing connections. During training, right, the weights and thresholds are continuously adjusted until training data with the same labels consistently yield similar outputs at the end. So some examples of artificial intelligence are Siri and Alexa. But to be clear, Siri and Alexa never really know you. They are simply taking data points and running them through their algorithms. Then they make extrapolations based on that. They can only operate off the data points that are provided, and they can only process these data points based on their algorithm. Some other examples are Amazon, Netflix, Pandora. These all use artificial intelligence. So we'll get close to wrapping up here, and I want us to look at this one particular question. So when people say that machines are getting smarter, they don't actually mean smarter. What they mean is they're getting more efficient, or that they're getting more advanced and more accurate. The smartness comes from the people who are writing the code and developing the algorithms. This question here is something that I was discussing with a colleague, and that is, what is the threshold that differentiates what we consider just a regular computer program with artificial intelligence? They are all, after all, lines of code. They are all, after all, algorithms based on logic functions. So where does it go from being a computer program to becoming something sophisticated enough to be considered artificial intelligence? Because there are so many definitions of what is and is not artificial intelligence, we don't have a completely clear understanding as a broader society. Something to think about too is it seems like this is always shifting, because every day we're getting more and more advanced. 20, 30, or 50 years from now, what we're doing today may not be considered artificial intelligence at all. Maybe what we're doing today might be just considered computer programming. And what they're doing 50 years from now is what they might consider to be artificial intelligence. Who knows? something to think about. So thanks to everybody for joining our lecture today. This wraps up our introduction to the basics of artificial intelligence. And in our next lecture, we will be looking more specifically at how artificial intelligence influences communication.